Hello my dear students, in this lecture we are going to see one previous year GATE numerical. This question was asked in GATE 2017 for 2 marks in set 2. This question is based on Rankine cycle. Now let us understand this question. Now the question is, in a Rankine cycle for a steam power plant, the turbine entry and exit enthalpies are. Now here the enthalpy at turbine entry is given 2803 kJ per kg and exit enthalpy of the turbine is 1800 kJ per kg respectively. The enthalpies of the water pump entry and exit are. Now here for water pump the entry enthalpy is 1 to 1 kJ per kg and exit enthalpy is 1 to 4 kJ per kg respectively. The specific steam consumption in kg per kilowatt hour of the cycle is. Now let us understand here Rankine cycle. Here in case of Rankine cycle there will be a boiler. This is a boiler, and from boiler it is the condition 1, which is nothing but entry to the turbine. Therefore this condition 1 is entry to the turbine. Therefore this enthalpy H1 is given 2803 kilojoule per kg, that is entry to the turbine here given, and exit of turbine is 1800. Therefore exit of turbine 2 H2 is given 1800 kilojoule per kg. Now after turbine there is a condenser. This is a condenser to remove heat. Now exit of condenser is 3, and this exit of condenser is a entry to the pump. Therefore there will be a pump. Therefore H3 is a entry to the pump. Therefore H3 is given 121 kilojoule per kg. 121 kilojoule per kg, and exit of pump is given 124 kilojoule per kg. Therefore 4 is exit to the pump, which is entry to the boiler. Therefore H4 is given 124 kilojoule per kg. These are the various enthalpies given. Now question is to find the specific steam consumption in kg per kilowatt hour of the cycle. Now the specific steam consumption is nothing but steam rate. Here this specific steam consumption is also called steam rate. Specific steam consumption is also called steam rate, SR, steam rate, which is nothing but 3600 divided by W net, and the unit of this equation is kg per kilowatt hour. Kg per kilowatt hour. So here our target is to find W net. From this we can calculate specific steam consumption. Now therefore my dear students, W net, net work output from turbine, is nothing but work of turbine minus work of pump, right? Therefore let us find this W net. Therefore W net is equal to, now turbine is between 1 and 2, therefore H1 minus H2 is turbine work, which is nothing but here H1 minus H2, minus work of pump. Now pump is between 3 and 4, therefore H4 minus H3 is pump work. Here H4 minus H3, this is a pump work. Therefore let us find this W net. Now my dear students, we have all the values, right? Here we have all the values. So work of W net is equal to H1 minus H2 minus H4 minus H3. Therefore is equal to H1 is given 2803 minus 1800 is H2 minus H4 is 124 minus H3 is 121. And if I solve for W net, the W net will be equal to 1000 kilojoule per kg. Answer will be kilojoule per kg. And here they are asking specific steam consumption rate or heat steam rate, also called steam rate or specific steam consumption, is nothing but 3600 divided by W net, which is nothing but 3600 divided by W net is 1000. Therefore it is 3.6. The unit will be kg per kilowatt hour. From this equation the unit will be kg per kilowatt hour. So my dear students, here they are asking what is the specific steam consumption in kg per kilowatt hour. Therefore for this question your answer in fill in the blanks you have to type 3.6 for getting full marks. Thank you dear students. In next lecture we will see one more numerical on Rankine cycle.